So let's solve some Leetcode question in Swift. So today is about the pushing the dominoes. So in the question, and it's mentioned that there's n dominoes in a line. We place a dominoes vertically upright in the beginning, and we similarly push some of the dominoes either left or right. So when you mention for the domino is like this, will be like 3 stage, leading on the left or leading on the right, or maybe the upright, not leading on the either of the side. So the question is, we need to simulate pushing the domino stage after the each second, each domino that fell into the left push the adjacent domino on the left. That means if the domino is like leading to the left, the adjacent domino on the left need to be leading to the left. So that means even the domino is lead to the left, that means it's a left stick. This is a situation like this. If we push this domino to the left, so it will be like this. So when the vertical domino is falling on from the both sides, have to still stay due to the balance of the force. For the dead line, that means if the domino leading on the right and then domino leading on the left, there's a one domino in the middle or in between. So that domino will be stand still since there's an adjacent balance of force from the left and right. So we need to represent the string in the final state. So the domino can be described in the character including in the string. L means that leading and push to the left, R for the push to the right, and then dot means the domino is upright. So let's go through the example. So in the example 1, it's mentioned like domino is the right, and the upright, and then left. So right means domino is this case, upright, and then left case. So let I iterate through each domino one by one. So for the example 1, if I'm not wrong, according to the balance force of left and right, so the result will be exactly the same as in both. Since the leading to the right 2 and the leading to the left is there's a balance in the middle of the one domino standing upright. So let's go through the example 2. So for the let's go through, let's draw a some diagram. Sorry about my ugly drawing. Left dot right, and then 3 upright, and then leading to the left, leading to the right, and then 2 upright, and then leading to the left, and then 2 upright. So in this stage, we need to iterate through what is the final stage of the domino if the changes are happening. So for first case, in the index 1 of the domino where we lean through the left, so it will be this. So how about I highlight with a different color, so much easier to understand for you guys. So this domino will be lean to the left, and then this upright will be the same upright. The right will be the lean to the right side. So that means to the right, I will highlight with the red color. So this domino will be right on the right side, and the upright will be the upright. For this one will be on the left side. So it means green means the leading to the left, and red means the green to the right. So it's the same, and then yeah, it's leading to the right is a red color. This one will be the right. Next is a green color, is this one will be to the left, and then the others will be the same. So if I have to draw for the next step, so the left, okay, I think I put right for the better understanding. Left, upright, and then right, up, right, and then left, and then there will be the red color is the right, left. This will be the left, and then the top. So I think this will be the final set. Yeah. Alright, let's move on to the start working on the Go base. So to push start working on the domino, we may need to directly edit the input. So how about we create the character of the strings. So you guys may notice I'm using the same variable names as the parameters, which make us to more easier to understand and more easy to catch up in the futures. So for the next step, I may need to create the queue, so which is going to allow us to keep track of the next stage of the dominoes. Let's keep it as a character, then will be the empty array at the moment. So first of all, we need to keep track of the domino that's going to make the initial false. Let's do it like index comma domino in. So it's going to give us the things like 0 comma r in our case. So what do we need? In this case, we need a domino that is leading to the left or right. So we can check like, not a domino, is a domino. Not equal to the dot. So not equal to upright means the domino is like either leading to the left or leading to the right. What do? We gonna append to our queue. So that's our first step. The next is we have to iterate through the queue and then do the next stack of the domino. Already we check the domino is empty or not. So we're gonna iterate through till the queue is empty, and then we're gonna remove from the left. That means remove first. Let's go like index domino first. So let's focus on the leading to the left perfects. So to check, we have to check with domino is leading to the left by checking like literally like checking the character is L or not, since they're given the leading left is L. If leading left, what can we do? We need to make sure that the leading one is not the edge one. What I mean is in this case, if the leading is on the index 0, so we don't need to do any action. So to pass this kind of step, we can start considering from the index 1. To check that, we can check by if index is greater than 0, so we can make sure that it start from the 1, and domino of the left index is upright. That means in our case, I'm writing about if this domino is leading to the left, and we need to make sure that the domino on the left is the upright. So if it is upright, we can strike it through, and then we can take over that domino to leading to the left. So -1 is upright. What do? We can directly move that one in our queue. -1 and strike it, and then we will directly update the domino value. 1. So next is if this is not the left, this is right. Why? Because we have already filtered the queue only involve the domino that is leading either left or right. To check that, we can use by the same as the checking to the right side. If index of the dominoes.count -1, that means, okay, how about we check it like that, +1, that means the right side we are checking is not the last index of the array, to make sure it is not the domino that is leading the right, is not the last domino. If it is the last domino, we don't need to like strike to the right side. So this is to check, and then we also need to make sure that dominoes of the index +1 is upright. So it's same as this one. If it is upright, what we can do? If it is upright, we also need to consider for the edge case like this one. So we are index of this, and then we checking the right side of our index is upright, and then the second right side of the next index is not leading to the left, to make sure we can strike this one successfully. How do we check? If index +2 of ES count, because we need to make sure that this is not, we are checking is not the second last of the domino list, should be the third left of the domino, so that we can strike to the domino of our index. +2. If it is left, what can we do? We can remove that first. So that case means our index here is leading to the right like this. Next is strike, and then leading like this. So we don't need to do anything. We just need to strike it. Else we can directly do it. One right, and then one to right. As a result, we can directly return the values in here. Let's see. Alright, we can successfully pass off the test kit. Let's try to submit it. Okay, we got the time limit AC. I think we can improve a little bit in our code base. Okay, so in that case, for the queue, we can use the array slide instead of the array. So what is the difference between array and array slide? So first I can explain is in array, if you do the things like remove first, that's literally remove the first item of the array, and then you try to recreate the array again. So for instance, I can mention it's 1, 2, 3 in our array. We want to do the remove first, maybe like 2 and 3. But if we use the array slide, what it do behind the scene is it's literally just update the first index to 3 and not recreate the index. So we can like 2 and 3 by just updating the first index, not recreate the whole array again. Let's try it. Nice. So for the time complexity will be O of n and then space complexity, I hope it's also O of n. Alright, actually if we want to do a little bit more improvement, we can still continue to do the improvements in our code just by updating it, like using the filter complement in here. I think we can leave it for now. That's pretty much for it. Thank you and see you in the next video.